Good. Unit 7 Test Study Guide, question number 13. For the set of data, make a dot plot, find the measures of central tendency and variability, and then answer the questions below. From this list of numbers, the only thing I'd really recommend you do is find the mean, which is, again, that is the average of the numbers. So you want to add these all together and divide by how many there are. Adding them together, I'd really urge you to first split it into groups so that you can add up a smaller set of numbers, and then add them up a couple of times to make sure you get the same answer both times. 9 plus 3 plus 8 plus 5 plus 5 plus 6. And so when I add those up, those add up to 36. And I don't really need to add them in again. I just need to check my list to make sure I got the numbers typed in right. So I know that's correct for that first set of numbers. And then my second set is going to be 11 plus 9 plus 8 plus 5 plus 8. Add those up. Those add up to 41. So add those two amounts together, 36 plus 41, and I get that these numbers add up to 77. And again, to find the average, divide by how many numbers there are. Count the numbers: 2, 4, 6, 8, 10, 11 numbers. So divide by 11. 77 divided by 11, that is going to be 7. So my mean, or my average, is 7. To do the rest of these, I would urge you just to, at this point, do the line plot, do the dot plot, as to get your numbers in order. We've got plenty of spots here. We really only need to go from 3 up to 11, it looks like, but I'm going to go ahead and number this anyway to fill it in. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And again, your dot plot starts with a number line. Then, plot each of your data points. I find it easiest for me if I read them off in bunches of 3 and plot them at a time. So 9, 3, 8 would be a 9, a 3, and then an 8, and then 5, 5, 6, a 5, another 5, and another 6. You should be trying to make your dots about the same size and placing them about the same distance apart. And then I have an 11, 9, 8, 11, another 9, and another 8. And then finally I have a 5 and an 8, so that is a dot here and a dot here. Okay, make sure you did this right. Count the dots. Make sure that you got every data point included here. There were 11 pieces of data. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 dots. I do have all my numbers located here, so I know my dot plot is correct. And so from this, I can put my numbers in order. So just reading them off as I go across here, I would have a 3. I've got 3 5s, and then a 6, and then 3 8s, and then 2 9s, and then an 11. Count my numbers again just to make sure I didn't accidentally miss a dot. 2, 4, 6, 8, 10, 11 numbers. That is my complete list, so everything is looking pretty good right now. The median is the middle number, and in order to find the middle number, you have to put the numbers in order. If they were scrambled, then every time you re-scramble them, you're going to get a different median. So you need to put the numbers in order. There were 11 numbers. That's an odd number, so there is just one number in the middle. You can do it by crossing them off. I prefer thinking about it of saying, if I have 5 on this side and 5 on this side, that's 10, and then I would have one number in the middle. So I like doing it that way. So 2, 4, 5. It looks like this is my middle. 2, 4, 5 numbers on this side. Yes, this is my median. So 8 is the middle number. The mode is what shows up most. Looking back at your dot plot, you can see the 5 shows up and the 8 shows up more than the other numbers. It's okay to have 2 modes, so go ahead and list them both. So the mode is 5 and 8. We have 2 modes this time. Okay, the range. Okay, those were your measures of center, the middle of your data. These 3 are talking about how spread out your data is. So your range is the distance, how spread out all of your data is. So that is going to be 11 minus 3. We are going to get a range of 8. The interquartile range. We need to split the data into quartiles or fourths. We've already split it in half with our median. We need to split the bottom half in half, again by using the median. There are 5 numbers down here. That 8 is directly in the middle, so it doesn't go to the lower half or the bottom half. That is just the middle of the data. So I've got 5 numbers here. That would be 2 on this side, 2 on this side. My 5 is my lower quartile. I think I want to put that above. That is my lower quartile. And then my upper quartile would be the middle of the upper half of my data. Again, there are 5 numbers here. It is going to be 2 in from both directions. My 9 is going to be my upper quartile. So my IQR is going to be how far spread out this middle half of my data is. So that is going to be 9 minus 5. My IQR, my interquartile range, is 4. All right. And then the last one, and the one that's probably takes a little bit more work, the MAD is the average distance of these data points from our mean. To figure out how far it is away from our mean, we are going to subtract the mean from each number here. So instead of writing those all in, I'm just going to put a -7 here and just understand that I'm going to subtract all of these. The other thing is the A stands for absolute. So the absolute deviation, the deviation is how far it is away from the mean. That's why we're doing the subtraction. The absolute means that we only want the positives. We want to think of them as only positives. So when I do 3 minus 7, it would be a -4. But in this case, I'm only going to call it a 4 because I want it just to think about the positive values. 5 minus 7, again, -2, but I'm just going to think of it as 2. Again, another 5, that would be another 2. Another 5, that will be another 2. 6 minus 7 would be -1, positives only. 8 minus 7 is also 1. 8 minus 7 is 1. 8 minus 7 is 1. Okay, 9 minus 7 would give me a 2. And then 9 minus 7 is a 2. 11 minus 7 is 4. That's how far each of my data points is away from my mean. I should again count them. 2, 4, 6, 8, 10, 11. Yes, there are 11 numbers. So I do have every data point taken care of. Add those all together. You want the average distance. The M stands for mean. You want the average distance. So find the average of these, add them together, which again, you could use the calculator. I'm running a little bit long on time here, so I'm going to run it through once. Well, I'm going to run it through in 2 groups again. So 4 plus 2 plus 2 plus 2 plus 1 plus 1 plus 1. I'm going to get that, plus one more 1. I'm going to get all the 1s in there. That adds up to 14 up to here. And then it's going to be 2 plus 2 plus 4. That is going to be 8. And then 14 plus 8 is going to give me 22. Sorry. Right up through there, that gave me 11. Right up through here gave me 8. 14 plus 8 is 22. And again, it's the average distance. Divide by how many numbers there are. So 22 divided by 11. My IQR, or my MAD, is 2. And then the last part of this, just answering these questions. What do each of these mean? What does the range mean? Again, the range is how far spread out all of your data is. So this means that the data, I'm going to call it data points because it's plural. Data points are spread out over, and in this case our range was 8. It's spread out over 8 spaces. That's the spread of all of our data. The interquartile range, that is this middle 50% of our data. And so this is how spread out our middle 50% is. So it is the middle 50%, or half, of the data is spread over, and again the IQR is 4 spaces. Alright, and then our last question, what does the mean absolute deviation means? This is the average distance from the mean. So it means that, try again, the average distance of a data point from the mean, that was what we that was the subtracting the 7 to find out how far away it was from the mean. So the average distance of a data point from the mean is 2 spaces, which means on this dot plot, our mean was at 7. If we put all of these data points the same distance from that mean, they would fall in 2 to this side, which would put them at 5, or 2 to this side, which would put them at 9. And that looks like the average distance if you line those all up. So that is question 13.